This is Mr. Beck Does Your Homework, AP Physics, Homework 8.2, question number 11. At 32 meters below the surface of the sea, density of 1519 kilograms per meter cubed, where the temperature is 8 degrees Celsius, a diver exhales an air bubble having a volume of 1 centimeter cubed. If the surface of the temperature of the sea is 17 Celsius, what is the volume of the bubble immediately before it breaks the surface, the acceleration of gravity is, and the atmospheric pressure is? Answer in units of centimeters cubed. So here I've got the surface, I've got some depth, and I've got this bubble initially. So here I've got a P1, a V1, and a T1. And I know that that is going to equal up here my P2, V2, over T2. But what is my pressure down here so deep underneath the sea? It turns out that my absolute pressure there is going to be, if you remember from fluids, rho GH plus my 1 atmosphere of 101,300 pascals. So my absolute pressure down here is going to be my density of 1519 times gravity of 9.8 times my height of, how deep am I? 32 meters. So that accounts for the water, plus my 101,300 accounts for the air. So that is my absolute pressure, P1. What's P2 going to be? Well, P2 is just the air. So here I know that P2 equals my 101,300. My temperature here has to be in Kelvin. Well, it gives me the temperature down there, 8 degrees Celsius. So I know that T1 is going to be 8 plus 273, and that'll give me Kelvin. My T2 is going to be 17 degrees Celsius. Well, that's going to be 17 plus 273. That's my temperature at the top. Now, since these are in, P1 V1 over T1 equals P2 V2 over T2, really, if I plug in any absolute values here, so an absolute pressure, that's what I'm dealing with these two. I plug in an absolute temperature, those are kelvins. Well, I can plug in any volume unit I want, and this happens to be in centimeters cubed. I don't have to convert it to meters cubed. I start off with 1 centimeter cubed down here, so my volume is simply 1 centimeter cubed. If I plug in pascals and Kelvin and centimeters cubed here, then I'm going to get pascals and kelvins, I'm going to get centimeters cubed up here. So I can use these values to solve for my volume 2 up top, and that volume will be already in centimeters cubed. So no more changing. It says the atmospheric pressure is 1.02 times 10 to the 5th. So anything I did over here, this is not 101,300, this is 102,000. And the pressure up here is going to be 102,000, because that's what it tells me here, 102 times 10 to the 5th. That's 102,000. Hopefully that won't mess you up too much. And I'm not sure if that's beyond 1%. It probably isn't. So good luck with that one.